Well, good morning and good afternoon, and welcome to today's National Soil Survey Center webinar. My name is Sean McVeigh, National Training Coordinator for the Soil Science Division, and host for today's webinar, the Digital Soil Mapping Focus Team. This webinar is being recorded, and all participants joined the webinar in listen-only mode. You received the webinar audio through your device's speakers. There is no telephone dial-in. If you are having audio difficulties, please check the various ways your computer speakers may be muted or have their volume set low, including the speaker adjustments available in the Adobe Connect interface. You can maximize your webinar experience in Adobe Connect by shutting down VPN and any other programs that might compete for bandwidth. This includes email and Microsoft Outlook and instant messaging in Skype. Taking a look at our webinar room layout, Adobe Connect has content pods that include the feature presentation, chat, and Q&A pods. Use the 4-arrow icon in the featured presentation pod to enter and exit the full screen view as you choose. To submit a comment or question for me or our presenters, use the Q&A pod and type in your question. I'll handle technical difficulties the best I can while hosting the webinar and interact with our presenters to answer your questions during verbal Q&A periods. I want to thank Tom DeVello for being here to support our webinar series and introduce our presenters for this 5th part of our webinar series on digital mapping. Tom, I'm going to turn the webinar over to you so you can introduce the topic and our presenters.
All right, thanks, Sean. And thanks everyone else for tuning in. Today, I'll be talking a little bit along with Suzanne Kinnis-Brown, who is the Regional GIS Specialist in Region 4 in Bozeman, and Dr. Jim Thompson, who's a pedology professor and our National Cooperative Soil Survey cooperator here at West Virginia University. And we'll do a tag team just so you get to hear all of our voices. All right. We got this digital soil mapping focus team, and we're just part of one of the 13 focus teams. I mean, by now, most everyone is familiar with these various teams, but yeah, the purpose of them is to get some people together, subject matter experts, and coordinate all across the Soil Science Division and also across the Cooperative Soil Survey. And the idea is to do some leadership guidance and coordinate within those specific areas and pretty much serve as the subject matter experts, and also too, act as a resource to disseminate that information and expertise and procedures, whatever, as needed across the entire nation. And within that, our digital soil mapping focus team, what we're charged with doing is focusing on this whole thing called digital soil mapping. And, one of those things, I'll qualify it, I always qualify it whenever I talk about digital soil mapping. To me, I take that DSM acronym, and to me, I just call it doing soil mapping. I really don't view digital soil mapping as anything different than soil mapping. It's doing soil mapping, just using the benefit of some additional tools and techniques. And in light of that, our whole thing is to try to coordinate all the various people that are doing these things within our agency, and also to work with our cooperators in other agencies and universities so that we can kind of garner and leverage all of our expertise. And one of those things was identifying training needs, and we've done that. Suzanne will be speaking a little bit more about that. Also identifying the need for some standards and proposing solutions. That also is being done with the development of Raster standards that are in review and maybe at some stage of review. one of the things that's part of identifying these gaps or needs is a proposal that we had come up with. It's taken off on what they've been doing for a long time in Region 6 in general and West Virginia specifically, and that's this whole idea of field weeks. And the idea there is it's an opportunity to assemble a relatively large group of people, focus on a specific objective or group of objectives, and collect a lot of information, collect a lot of data related to soil survey. And when you do things like that, you bring a lot of people together, you're focused on a fairly narrow range of objectives. They're collaborating, they're learning as they're doing this work. And, you know, when people go back to whatever office, you know, their home base is, they're taking back information and processes and procedures that they've learned during that week. And it's been a pretty beneficial thing that they've been doing here in West Virginia, and they've expanded it in Region 6. And it would be a good opportunity to expand that nationwide. And, you know, it'd be one way to generate and improve and get many people sort of on the same page regarding some of these technologies. You know, as part of assembling existing data, that's kind of all part of identifying the various gaps that we've got. So whether they're dealing with gaps in knowledge, gaps in data, you know, both data that would be used to do the inventory, gaps in our inventory itself, just putting all those things together. And, you know, our whole focus with the Digital Soil Mapping Focus Team is raster data. You know, we've got vector data. It has and it is providing all kinds of valuable information to our users. But, you know, we also need to consider that we can adopt additional data products and utilize strengths that these other products provide, such as the raster data format. So we don't really have to confine ourselves, and we shouldn't confine ourselves within NRCS and the National Cooperative Soil Survey with one data product, Surgo or StatScope, all based on the vector data model. We can expand beyond that. And, you know, I've already introduced our group, but these are the co-team leads, myself, Suzanne, and Jim, and provide a little bit of history. You know, if we stretch the timeline and are a little bit liberal, I mean, the start of Landsat in 1972, in my mind, was the start of digital soil mapping activities within the Cooperative Soil Survey. I mean, shortly after that launch, the laboratory for the application of remote sensing was set up at Purdue, and our cooperators there at Purdue, probably Chris Johansson was the main individual, but all of the pedologists at Purdue got involved in that research. So we've been at this a long time, just not super engaged. So we sort of look to when we started getting more fully engaged in this. It was 15, 16 years ago, 2002. Since that time, there's roughly been 25 to 30 projects that at some level have employed some type of digital soil mapping technique. And these have been soil survey updates. They've also been initial projects. They've used all manner of methods. And, you know, that information's been incorporated. And, you know, recently, in the past 4 or 5 months, 6 months, you've heard about some of those specific projects and some of the specific products that have been provided for that. As part of that too, probably dating back to 2012, NRCS was involved with the Global Soil Map initiative, and you know, the first release of that data, well, 2 releases, were the StatsGo implementation of Global Soil Map, and then this StatsGo Survey blended initiative of the Global Soil Map. And there's probably 15, 20 soil scientists that are right now working within NRCS that have some level of expertise and have been employing digital soil mapping type techniques and methods to do their work. And, you know, we got a host of cooperators, mostly in academic institutions, but also, you know, quite a few within the Forest Service. So if we look at that, the focus team itself and our history there were a number of, you know, Raster workshops and discussions that took place back in, from 2015, March of 2015 to roughly February of 2016. And these took place in Amherst, Mass., St. Paul, Minnesota, Davis, California, and College Station, Texas. And they were kind of a combination of listening discussion sessions, and pretty much the first time that NRCS in earnest started bringing up the topic of, you know, raster data, raster format, how can we use it, should we use it, what are the opportunities. Just, they were fairly wide-ranging discussions to pretty much, like I say, introduce the idea. And probably as a result of that, in February, a digital soil mapping team was initiated. Suzanne and Jim and myself met in Morgantown and pretty much had a no-holds-barred brainstorming session. We were really provided, as it stated, no sideboards. Really the idea was, look, see what you guys come up with, and what we're really after is, by 2026, we'd like the entire nation mapped. And I would say that was the extent of our charge, which was pretty good because they gave us free rein to think of all different kinds of things. And, you know, I would say within the first 30 minutes, we went from fill in the gaps, which is, let's just see where we don't have any Surgo data and what we could do to complete those, to this continuous suite of soil properties at specific depths. And like I say, I would say within the first 30 minutes, maybe the first hour, we went from filling gaps to doing this soil property thing. And the reason is if the only thing we focused on were the gaps and the conventional Surgo way of doing things, all we would be doing is perpetuating the patchwork and all of the multitude of things that are related to that patchwork. And the other thing too is the whole idea of the realization that as a National Cooperative Soil Survey, we can produce and deliver more than one product line. So the whole idea of multiple product lines for multiple uses, serving multiple users. And, you know, the users are not just other people. We're including ourselves, NRCS, and, you know, field offices, and our technical soil survey people, and everyone else in that mix of users. So, you know, we were, I think, pretty complete and comprehensive in that definition. And in January of a year ago, you know, there was a formal designation of, here, let's have a new focus team, and we'll call it the Digital Soil Mapping Focus Team, and that's kind of where we're at now. And, you know, the designation of that has presented quite a few challenges. I mean, of the 13 teams, this is the one team where we've got nothing sitting in front of us that Soil Science Division has been involved with in terms of procedures, data products, data standards. I mean, there's nothing out there. And we're proposing all of those things and having to deal with all those things. And I will say there's a bit of resistance. And maybe not everyone is super enthusiastic about these things. And yeah, as part of that, I'd just like to make note of a few things of the way soil survey has operated over the past 120 years. You know, it took 10 years for soil survey to adopt aerial photographs as a base map. So when those first soil scientists came back from World War I and started touting aerial photography, there was a contingent of plane table mappers digging their heels in. And it took 10 years for those plane table people to yield to aerial photographs as a base map. If we look at Surgo itself, it took at least 5 years to develop a Surgo standard. And after that first draft of the Surgo standard was developed, it went through countless edits and drafts. And once that Surgo standard was developed, there were another 10 years that elapsed before Web Soil Survey came about. And all of these things, especially related to Surgo, all of these things were dealing with a data format and a data delivery system that was pretty much commonplace. Everyone that was doing GIS in 1995 or the year 2000 had some type of GIS system that could handle polygon data, and they could handle a database. So there was really not a lot new when all of this was going on. And yet, we were still doing things. We still had various states digitizing soil surveys and providing things and providing data that people could download 10 years prior, 15 years prior to Web Soil Survey and the Data Gateway and any of those things. So we got a history of moving forward before everything is figured out. I mean, in soil survey, we never figure everything out before we take a next step. And that's kind of where we're at with this focus team. You know, it's proven. There's plenty of people that have produced good products, pedagogically based, using this new technology and new techniques. We don't and we can't throw out any of our pedagogical knowledge and we don't propose that adopting these things is going to require that we throw out any of our knowledge in order to produce these products. And with that, I believe Suzanne is going to pick up the next set of
Thanks,
slides.
Tom. So as Tom mentioned on the last slide, we have a unique challenge with this focus team, but there's this really great, unique opportunity. And we're all very passionate about implementing these methods and using new technologies and producing relevant products, and sort of been waiting for somebody to say, hey, here's this challenge, go for it, make it happen. So we're trying to make it happen, and we've got a lot going on. I'm going to talk about the things we've been up to. On the last slide, we talked about the need for standards, training, and delivery. So that's where we've focused our energy in the last year. So as far as standards go, there are draft standards that should be published soon as part of the National Soil Survey Handbook Part 648. And these were developed with input from many people within NRCS, went out for a larger review, also been reviewed by the standards team at the Soil Survey Center. So they've gone through that review process and they're ready to be pushed up. The standards are focused on the Raster products, just like our Surgo standard is focused on the vector product. So we're not focusing on how to arrive at these products, but what should the products look like, what requirements do they have, and really just focus on the product delivery. So in terms of training, that's where people learn the process. So you go through the training sequence, you learn the process, and you practice applying these methods. We were able to identify a curriculum from existing courses. So we had all of these courses in place already. They just weren't organized into a DSM curriculum. We've done that, and we've added this Introduction to Digital Soil Mapping course, which had existed previously, and we just revamped it to better support the training that's in place now and where the current state of digital soil mapping in the division. So we developed that course and we taught it a few weeks ago. The idea with that course is that it's meant for everybody to take. So no matter what level you are at in the division, that course provides a foundation for further training, but it also provides a foundation so that everybody has this kind of base knowledge and understanding and terminology. We can talk to each other about digital soil mapping and these Raster products. So I'm sure many of you are familiar with this training curriculum that we've put together. We have these 3 foundational courses, the Spatial Analyst Workshop, the Statistics for Soil Survey Part 1, and then the Intro to Digital Soil Mapping. And they should be taken in that order. When you get to the Intro to Digital Soil Mapping, it's very helpful to have those other 2 courses to support your learning in that course. And then from there, we have these 3 more advanced courses, the SIE course, the Statistics for Soil Survey Part 2, and then the Remote Sensing for Soil Survey Applications. And you can branch out and take those in whatever order you want, not take all of them. That's sort of up to the discretion of your training development and your learning plan with your supervisor. We also recognize the need for a more advanced digital soil mapping course, and that's something that we want to focus on in the future. So it would build on these 3 courses that are listed at the bottom, but it would also address some topics in more depth than are introduced in these courses, and other topics that we don't touch on in those 3 courses. So we have Raster products out there now. We have GSurgo, we have initial soil surveys that have been completed and produced a Raster soil survey product. Those thinking of Boundary Waters and Essex County, and then we have an update project from North Dakota that has a Raster soil survey. Those products currently live on the gateway. That's our option for Raster delivery at this point. It's arguably not the best solution because it's not very visible. It's not like going to Web Soil Survey and seeing that we have Raster products sitting there. So certainly there is a need to develop something different, but and we are focused on that future delivery. But right now we need to figure out what can we do with the resources that we have available to us now. So we have the data gateway. Now the database focus team is working on this GNATSCO product as it's the tier 1 in the Soils 2026 effort. And this GNATSCO product is a gridded SurGo-StatsGo blended product. So StatsGo in places where we don't have SurGo. What we envision for this is that this could be the container for our Raster soil surveys that we produce. So our update projects, our initial soil survey projects, they could just be plugged into this existing structure of the GNATSCO and replace whatever data would currently be there, either SurGo or StatsGo. And this kind of future GNATSCO product would be what would be our best available data, class-based data, so same type of information as is delivered in our SurGo product now. So that's a solution that we can attain in a short period of time. For future delivery, we obviously recognize the need for some kind of interface like Web Soil Survey that allows users to both download and interact with our data. So generate interpretations. And we see this, there is a need for this for our Raster class products. So products that are component or map unit based, being able to interact with those, generate interpretations just like we can now with our vector data, and then also a delivery mechanism for these nationwide continuous soil property products. Also with the ability to generate interpretations from those continuous soil properties. So there is some effort now at looking at the GIS architecture for Soil Science Division and delivery of these Raster products and interactions with them is one of the pieces of that evaluation. We've initiated several projects with our partners. We have a project in the Cascades region. This is in coordination with Forest Service, New Mexico State University, and USGS. We have a project starting up in the Bob Marshall Wilderness of Montana. This is a collaboration between Forest Service and New Mexico State. Well, NRCS is clearly involved in all of these, but those are our partners. There's a project in the White Mountain national forests in New Hampshire and Maine with Forest Service. In Alaska, we have explored 2 potential areas to get some projects going up there, and potential partnering with University of Minnesota and ADR, which is a private firm in Alaska that's doing a lot of raster-based, I would say, more ecological mapping, where they're incorporating soil, landscape, and ecology information. And then there are some update projects going on. So there was the one in North Dakota that was finished that was just presented a few weeks ago. And then there are a couple new ones starting up in that same region. So in Region 10, a couple more update projects focused on implementing digital soil mapping methods and generating raster products. And then we have this nationwide continuous soil properties project. We have many collaborators involved with that project from Forest Service, USGS, and universities. We also are focused on organizing some sub-teams. So we have asked for volunteers, people that want to participate on the focus team. We would encourage, if anyone is interested and hasn't volunteered, check with your supervisor, get in touch with us. We are always open to including as many people as possible. So we're in the process of organizing these 3 sub-teams, one to focus on initial mapping projects, one on MLRA projects, and one on the national coverage soil properties. And I'll explain a little bit more about those here in a minute. Okay, so that was a brief overview of the current activities we have going on. We're going to change now and kind of give you our vision. So Jim and I will present our big picture vision for digital soil mapping within the division and the National Cooperative Soil Survey. So as Tom mentioned earlier, this is soil mapping, just soil mapping, same as we've always done. We're just using a different set of tools. So we're still very focused on pedology, and I hope that there is never a time when that isn't the focus of our activities. We need to keep expanding our knowledge of the soil resource. That's what we do. That's what we love to do. That's what we're good at. So we're very much focused on that. So expanding that knowledge of the soil resource is going to require interpretation and analysis of existing and newly acquired data. So we've got to go out in the field. We've got to get out there, feel the soil, look at the landscapes, still strive to understand those soil-landscape relationships. That is only going to make any product we produce, vector-based, raster-based, whatever, it's going to make it, it's going to improve it and make it the best available data that we can produce. While we're, focused on that fundamental piece of pedology, we are very interested in trying to adaptively apply these new technologies that are available to us, this new set of tools, and we'll do that in combination with our soil knowledge. So we're never going to leave that soil knowledge, that pedology piece, the understanding of soil landscapes. We're never going to leave that to the side. It needs to be incorporated into what we're doing. So these tools and approaches are scalable and cross-informative. So we can apply these same methods to initial projects, local updates, MLRA updates, national scale products. they go across the board. Are you going to apply the same tool in all situations? Probably not. Every situation is unique. You need to decide on the best tool for the job. If you don't need to lug around a Montana sharpshooter, you're not going to do it. You're going to take a lighter spade. Same idea, but choose the appropriate tool for the project that you're working on. If we're producing information on initial soil survey projects, that information can inform things that we're doing at the national scale and vice versa. If we're producing nationwide continuous soil property information, that can help inform MLRA updates and initial soil mapping. To support these activities at all those different levels, our sub-teams come in. So we have the initial mapping sub-team and the MLRA update sub-team that have more of that local focus. And our idea with these sub-teams is that they become the place for discussion and coordination of individuals working on these kinds of projects and implementing these methods. So setting up regular meetings where people can come together, you can bounce ideas off of each other. If you don't have the support or resources that you think you need to be successful in these methods, then these would be the places where you would come and we would see what we could do to help you out in that manner. For the nationwide products, we have a team that is focused on these continuous soil property projects and the products that will result from that. And that team is comprised of NRCS folks along with our National Cooperative Soil Survey partners. And that team is, we had our first meeting yesterday, so the ball's getting rolling on that. The initial and update teams will get rolling here shortly. We will have information on our focus team website about when the regular meetings for these teams are happening so that people know when they can join in and become part of the discussion. With that, I'm going to turn it over to Jim, and he's going to talk about our vision for deliverables.
Thanks, Suzanne. This has been previewed in some of the comments that Tom and Suzanne made, but obviously one of the outcomes of our focus team is to push forward and guide some of the development of these soil survey products. We know that we have a diverse set of end users of our soils information, and we believe that our soil survey products can't be a one-size-fits-all choice. And so we're going to talk a little bit about a specific product that we see as being complementary to some of the other soil data products that are already available, and but also want to recognize that these products are adaptable in the future, and as needs change, as technology changes, the soil survey information products that are available should be adaptive to that. And so, but one of the first things that we see as being important within the realm of meeting, in particular, meeting needs that aren't necessarily well met with the traditional data products that are available through the soil survey division, is a Raster soil property data set. And so this would be a gridded data set, and instead of representing classes, it would represent individual properties, and it would do so at different depth increments. And so, and I'll mention some of these key soil properties in a moment, but we've divided the profile into these 6 depth increments, and the properties would be represented as averages over those depth increments. So whether it's 0 to 5 or 15 to 30 centimeters, 100 to 200 centimeters. Also, what we've learned is important to some users is not just to have a value of a specific soil property at a given depth, is the uncertainty associated with those values. And so we want to then provide a prediction interval. And this usually takes the form of, so it mentions a 90% prediction interval is the value that represents the 5% and the 95% within the distribution of those data. And so that's part of the structure of this proposed deliverable would be this raster data set of key soil properties at 6 depth increments that includes not just the property value, but a prediction interval. And in some ways, this is similar to the way we structure some of our data in StatsGo and SurGo with the representative value and a high and low value. Specific to those properties, ideally, over time, we could have any number of soil properties that we provide to the end user. But we're starting with what I consider a sort of the minimum data set of these 12 soil properties. It includes the total soil thickness, which would essentially your depth to bedrock. The plane of exploitable soil depth is more your depth to root limiting layer, so the depth to a fragipan or depth to a cemented layer. Organic carbon at those 6 depth increments, pH, sand, silt, and clay content, rock fragments, effective cation exchange capacity, bulk density, both represented as the fine earth fraction or rock-free bulk density, or the whole soil bulk density, which includes the rock fragments, and available water holding capacity, again, at those 6 depth increments. And so you'd have this essentially a raster stack of all of these different properties at all the different depth intervals. Now, again, this represents what we think is the first property that we could, first product that we could get out there to meet some of those user needs. Obviously, there's other types of data that will be wanted by different user communities. And so we could still be producing raster class, for example, data sets, whether that's the taxonomic class or some other class of data. So it doesn't have to be continuous properties. It doesn't have to be a property that is represented by multiple depth increments like we do with depth of bedrock. And then further down the road, once we have these products available, then the interpretations side of it can be further developed, and where we bring in some other data sets like topography or climate for managing and creating these interpretations, just like we do with the SurGo data set today. And another thing that we think is important within the framework of these deliverables is that it is an iterative process, and that as we learn more, as we collect more soils information, as our ability, as remote sensing data or other environmental covariate data becomes better, that we can improve our predictions, we can add additional properties, and otherwise broaden that suite of data products that we can provide to these end users. And again, this idea of continuous investigation and improvement. We know that the soil maps that we have today are better than the soil maps were 50, 100 years ago, and we should fully expect that 50, 100 years from now, that our soils maps, our soil data products will be able to be improved as we have access to new technology, a new understanding of soils and landscapes. And some of you are probably familiar with some of these products that already exist in this idea in this realm of raster soil property maps, in addition to raster soil class maps that have been made available. The Global Soil Map product was mentioned earlier, and that was recently released by the Soil Science Division in two different versions, one that is based on StatsGo alone, and then a second version that is a hybrid between StatsGo and Surgo, conforming to those global soil map standards. And I failed to mention earlier with some of those ideas that we had, that I just discussed, about the formatting for these raster property data products are derived from the global soil map specifications. And so not only are those specifications have been lengthily discussed and well vetted by the soil science community, any products that we create that conform to those specifications would be compatible with similar global soil map data products from around the world. Another example of property, raster property coverages that are available are the soil grids products. And again, some of you may be familiar with this, and I'm going to show you some examples of the soil grids products here in a moment. It is available globally at two different resolutions, 1 kilometer grid cells and 250 meter grid cells, and a recently developed version of it just for the continental United States is 100 meter resolution property prediction rasters. And these are derived from point data, including the pedons in the NCSS soil characterization database. And then a third product that is in development is this another hybrid data set that uses both Surgo and StatsGo to make soil properties and interpretations, and it's at an 800 meter resolution. And that's being developed and should be available soon. And so even just these examples that are available already give us an idea how, as we improve our methods and broaden our knowledge base, so as we learn more about the statistics and the modeling and the GIS side of the process, as well as the pedological side of the process, learn more about soils and landscapes and how we can characterize them, that we can make more and better products for our users. So the next three slides are some images of the soil grids data. This is at a 250 meter resolution data set. And I'll just show you a little bit about what's on here and what you can do with the data viewer here is, and so this is the depth of bedrock for the area here in the window. And it shows here down at the side, you can see the units. So the darker reds are the shallow bedrock, and the lighter colors are the deeper depths of bedrock, up to 200 centimeters. And this is for an area in Montana and Wyoming. in the western U.S. Our next figure shows another soil property. This is organic carbon content, organic carbon stock, tons per hectare, for the 0 to 15 centimeter depth increment. And this is for the Washington, Oregon, in the Pacific Northwest. And again, you can see the units down here in the bottom where the blue colors are the lower organic carbon content, and it increases into the greens and yellows and reds. Like a lot of data viewers, you can zoom in and out and change the area of extent, change some of the opacity, so you can see in this case, the underlying topography under the data. And then the third example is for this same extent, but for clay content. And so this is the clay content at 30 centimeters depth. And again, 0 being, or the yellow colors being the lower clay content, and the blue colors being the higher clay content in this extent. And so, just like we do with Web Soil Survey and other data viewers, we can view and explore these data, and it's just in a different format with the raster and like we've done with GSurgo, these properties have been pre-calculated for the user. Okay, so those are just some examples of what the raster soil property products might look like, and what we feel is the benefit, or really our goal for whether it's just our DSM focus team or really for Soils 2026 and the Soil Science Division as a whole, is a complete, consistent, correct, comprehensive, and current inventory of the soil resources of the United States. That's what drives the decisions that we make and the products that we can provide to these end users. And I think that all 5 of those descriptors are representative of what our goals are for the soils knowledge that the Soil Science Division, that the National Cooperative Soil Survey provides. And so I'm going to, our last slide here is well, before I get to that, just a couple other thoughts on this. All right, so by providing this type of inventory, we need to be flexible in terms of how we produce the products and how we provide them to the end users, and that's going to help the inventory remain relevant. Helps us to adapt to changes in user needs as different challenges arrive, different questions arise in terms of what people are asking of our data. It also allows us to provide data at multiple scales. Again, we want to make sure that the products that we provide are commensurate with the questions that are being asked. And so again, this last image is and this is some output from Joe Brennan in Minnesota, and some work that he was doing to compare the Surgo data products to a higher resolution of rasterized data product that would, once we start talking about soil interpretations. And so you can see with this more aggregated approach in Web Soil Survey, you have a small number of map units here, and they all represent the same rating in terms of, in this case, it's conservation tree and shrub group. But with a similar extent, by using a more disaggregated or rasterized data product, you can then represent some of that within map unit variability, that finer scale differences that highlights the truly poorer sites, and then as well as the more suitable parts of that landscape. And our overall, I guess our final point, and this is something that Tom and Suzanne I feel strongly about, is that the things that we do should be allowing us to provide the best available data about soil science to these end users so they can make the best possible decisions about their land. With that, I'll turn it over, or turn it back to Suzanne and Sean.
All right. Well, thanks. We'll give people a moment to compose their questions and enter those in the Q&A for us. But to start things off, I'll go ahead and ask a question. So what was the data viewer that was being used for those three examples that you showed, Jim?
That is the Soil Grids website, and it's a integrated viewer for the soil grids. And I'm not sure if it's probably something very simple like soilgrids.org or something like that. But let me look it up. It is soilgrids.org. And so let me see if I can I just do this?
You put that in the chat. Sure, that works good.
Wow. You could hardly tell this is my first webinar. So it's a really nice viewer, and it allows you to, and since it's a global data set, you can view anywhere, not just the Pacific Northwest. And you can then also download the gridded data sets and use them and manipulate them yourself. So if you're more GIS savvy, you can work with them outside that data viewer.
Sounds good. I'll go ahead and ask another one. So could you give us some examples of users requesting the continuous raster products? And that's
Suzanne,
for any
Tom,
of you.
you can feel to chime in also, but I'll, I think the example that comes first to mind are some of the modeling community. Some of you familiar with Nate Cheney and his work with Polaris. That he's a hydrologic modeler, and that product development was driven by his needs for raster property data sets that provided if I'm going back to my 5 C's there, not just that it had to be complete and consistent across large aerial extents. And for better or worse, when you take our Surgo data and create those property layers directly from Surgo over wide areas, we know that there are gaps in the data set, so it's not complete. And we know that we have inconsistencies often at county or state boundaries. And so that's what drove his needs for those types of raster products. And I think there are other examples, whether it's hydrologic or climate modelers or other land use modeling at broader scales. So not parcel-based or county-based, but regional, national, even global.
And I think I would also add that one of the attractions of these kinds of products, the continuous soil properties, is very flexible. So it can meet a variety of user needs. Now, perhaps the biggest draw for these projects currently has been modelers or people looking at very, broad scale issues or questions. But as these products are available to users and they have some information about how to apply them, they can meet any of the user needs that we currently have. So I think it's one of those things, if you build it, they will come type of thing. Once these products are out there and people have access to them and knowledge about how to use them, I think we'll be surprised at the uses that we see.
Mm-hmm.
And just add to that, I think Suzanne makes a good point about the build it and they'll come, but the other aspect of that is, and I think we've seen examples of this, if the NCSS doesn't build it, somebody else will.
And we won't like it. That's what's been happening, right? So we should be the ones building this data.
Yeah, I think in many respects, our greatest strength has also been a limitation in a way. Our greatest strength is just the infrastructure that we've got as part of the Cooperative Soil Survey. We've got tons of soil scientists. We've got the National Soil Survey Center. We've got the laboratory. We got all of our land grant cooperators. And the thing that our team thinks can happen is just take a little bit to where we can leverage all that expertise and apply it to improve, what a lot of people have been out screaming in the wilderness doing on their own. One person that's a hydrologist or two people that are geomorphologists and, really good at manipulating data, but not a lot of pedagoggical expertise. So, I think that's the opportunity that we see is we can engage our people, apply our expertise to these things. And the other thing, too, is I could easily see our people turning around and using those soil property data sets in kind of the traditional type of mapping that we do, the class-based stuff, and making improvements to both data products in doing that endeavor. So
cross-informative.
Exactly.
So James, your question about the resolution, the standards state that the resolution for the Raster class data, so data for initial soil survey projects and update projects, is 10-meter resolution, just like our GSERGO data. Of course, you can change the resolution of a raster with a click of a button in ArcGIS. So you need to understand what you're doing and how you're affecting the data, but it's fixed in the sense that there's a resolution stated in the standard, but once that gets into the user's hand, there's flexibility there.
All right, there's another question in the chat, or excuse me, the Q&A, and it's about the effort in the Soil Science Division to have people in each region nominated to be the go-to people to kind of shepherd digital soil mapping projects along in their region. Can any of you speak to, the activity there and what's the status of moving forward with those representatives?
So that is a little bit out of our hands. That's up to the individual regional directors, how they are pursuing and pushing that along. I know, for instance, in our region here, Region 4, we identified 2 individuals out of our soil survey offices to push forward, through the training curriculum and get them involved in those roles. But I don't have a lot of information about what's occurring in other regions. I think similar efforts are moving forward in each region. But, the key to that is if there isn't somebody already sitting in a region with a certain level of expertise, then, they'll require the training curriculum to help them get into a position where they are comfortable with helping others.
Kavindra has a question in the Q&A. So how good are those new SoilGrid 100 meters over the 250 meters in terms of map quality, and has any comparisons been made so far?
Jim, I haven't, I would assume that it's better, but.
I was just pulled up the manuscript that Amanda Ramcharan published on the SoilGrids 100. If you haven't seen that, Kavindra, you let me know and I can forward it to you. But it was in SSAJ earlier this year. One of the challenges with that is that the SoilGrids 250 was actually an input layer, one of the covariates that was used to create the SoilGrids 100. And so it's difficult to compare the 250 to the 100 in a fair way because the 100 meter resolution had access to the 250 meter resolution data set as one of its inputs. And so I'm not, in that respect, I don't think they did a full-on comparison of the SoilGrids 100 to the SoilGrids 250. I think they did compare it to the SoilGrids 1 kilometer, as well as Sergo data, and that's described, like I said, in their manuscript.
So lots of people are asking about point data. Everybody knows the point data is all over the place. The database team has an effort that will focus on some kind of procedure to do some QC on that. In terms of the continuous soil property mapping, that effort will use the characterization data and other data sources that have measured property values. So maybe that helps clarify a little bit. And Jim, you can add anything you want to that.
No, I think you covered it.
We do have another question that's come in from Marissa, and she asks, what can non-NRCS National Cooperative Soil Survey members do to encourage digital spatial updates in their area?
So if you want to encourage NRCS to pursue those in your area, I would suggest participating in the management team meetings. I think, Marissa, you're with BLM now? But there are opportunities to suggest projects and work focus for those MLRA offices as part of the management team. So I think I would encourage you to pursue that.
And I'll just add to that that our non-NRCS federal partners are certainly welcome to participate in our trainings that were mentioned earlier in the presentation. All right, well, it looks like we've exhausted the questions that have come in. So thank you to Tom and Suzanne and Jim for your time and effort to make this presentation, and thanks to all the participants for joining in. We had almost 150 people join today's webinar. The on-demand recording of this webinar will be available on our Soil Survey Center YouTube channel within a couple days, so feel free to let your colleagues know about this training opportunity. This concludes our webinar presentation.